boob area. Then there would be, so it would be skipping neck and then be skipping the rest of her body and then something else. So it'd be skipping portions of the body, right? So we have the top and the bottom, but the middle is missing. So this is a RAID 0 with 2 drives in it. And I know because I did it, but so I get this, and I got 1 drive in the mail, and I processed the 1 drive, and I spit out a bunch of pictures, and I start looking at them, and I'm like, what the? And I call the guy, and I say, hey, is there another drive? He goes, yeah, I know you charge by the drive, so I only sent you the one that was broken. I'm like, oh, good luck, all right. Yeah. So he did eventually send me the other drive, we did get that, but that was the way this one went. So this one, now again, I'm older than everybody again, but these are actually 2 Windows bitmap pictures that are built in, and this one's actually correct. It's not like a blur or snot blob or something like that. It was like an iceberg or whatever it was, I don't know. But these are actually 2 Windows pictures that are defaults in Windows XP or something. So if this file is 140K, what slice size do you think I have? 2K? Why do you say 2K?
Yeah, I mean, as we said, the slice on the bottom is kind of tiny.
Yeah. So if, let's say that this file, when I carve it out, now keep in mind the way a RAID array works is it has all the space is just laid out together. And so let's say in this particular instance, it may not be a RAID 0, RAID 5. It depends on what you're looking at as far as the picture. And in this particular instance now, you still may have a boundary that things are coming over on that is uneven, because when you have your slices in the wrong places and you have your drives in the wrong order, you'll have overlap of things that don't belong together into a new section. But these 2 pieces belong together. Right? So when I see this, my first thought is this. If it's about 140K, what are my segments for slice sizes? Let's just 32, 64, 128, and then 256, right? So if it was 256 and I had a chunk and it was all a slice of 256, what would this picture look like if it was 256? If my slice size is 256, what fits inside of 256? 140. So the picture would be solid and it would be good. It would not be a separate slice. Does that make sense? So if my picture, yeah, see, so what happens is if you start thinking about where the segment starts and where the segment ends, so 140 is not a good number for us to calculate, so the next one down from there is 128, right? So you chop off a little bit and you get to 128. At 128, you divide in 2 for the next segment that you have. So I start counting down good parts. So I count down to where I find something and it starts to look like, oh well, this is a 16K slice, a 32K slice. It's actually physically going to work out almost physically by size. Like it's a puzzle, and here's where it came up. Here's where I came up with, as I started looking at more and more, like I processed hundreds and hundreds of RAID arrays, and when I started looking at them, here is what they started to look like to me, and this is how I came up with the idea. You've seen these things before, right? I'm not kidding you when I tell you, this is what it starts looking like. So when you start pouring your JPEG in, it fills the first segment, then the second segment, then the third segment. Now if you have a RAID 5, depending on how many drives you have, the last one in the segment is parity. So parity, it tends to cause a blur. You start to get a little blur right here. And then the next segment, now you'll see when you see the algorithms that what the order of the squares is. Because there's some things that are exactly the same and there's some things that are different. And so always at the top, all of the segments are the same order in all 4 variations depending on what it is. So you'll fill the top row. It'll be the second row and the third row and however many drives you have. that the order starts to change. And you will start to see this happen. That will actually be, if the picture is in the same codec, the same process, can be processed. Now when you throw off some of the graphics, sometimes the colors will change. So you'll get a variation in color, but you'll be able to tell the difference in the picture. And then you'll actually get to a spot where you'll be like, if I only do like a Rubik's Cube does and focus on one side at a time, you focus on this, you focus on this, you focus on this, eventually it just starts to build and it starts to come together. Now, here's the other thing. This is drive 0. This is drive 1. This is drive 2. And this is drive 3. They're in a cylinder format. So the data that's poured into them comes across the drive. So if you're physically looking at it, pours in, pours in, pours in, and then each one of those is a rotation of the drive. If you take your drives and you rotate them, that entire chunk comes into another order. So you'll slowly start to see. So you rebuild the top row. Then you rebuild the second row. And then by the time you're done with that, it's over. You have the whole thing. It'll just work. So you'll get used to seeing enough of them that it'll start to make sense. So you'll start seeing this. These are all off real drives. So this is our 32K small files. So if you have a 64K slice, every picture that's under 32K, with one exception. Keep in mind, your cluster boundary isn't defined by the hardware specifically. It's still an operating system thing. So you can still have some small problems that things overlap and they sit in the wrong place. You can still have fragmentation. You can still have a picture that has a Word document in the middle of the picture. Does that make sense? So you have to start taking a sampling. So you can't take just one. I have to take like 200. And then when I look at 200, I always look at the largest ones first. If the large one is right, if it's like 2 meg, and if the large one's like less than 64K, then that's not good. But if it's a 2 meg picture and it's right, you can't be wrong. You have your order done. So you just focus on your big pictures till you figure them out. The size that it will tell you of the photo that you are looking at, if it is incorrect size. Because it doesn't know the size, you can calculate your size. So I'll show you what I mean. This is a thumbnail. It's small. It's embedded in a picture. I can pull the thumbnail. It looks fine. You can see the clouds. You can see the whole thing. This is the real picture. Comes off the RAID array. Now, ignore color. Color, once a bit shifts, color's off. But you can see, even though it's not as good in good shape, I've got the clouds. I've got the top of the clouds. And as it will turn out, the drives, at least for the arrangement that they're in, the top row is correct. That part is correct. The orientation that affects the second row is where it's wrong. And once I get them in the correct order, it will come back correctly. And then, so here's another one. The top of the picture, you can see this part. Now, this is London and London Bridge or something. So you can see that this part, if you know anything about, like, this goes here. This is supposed to be here. This row is right. It's hard to tell because it's only blue, but it's evenly blue and it's a blue sky. And so if this part was over here, this would be the top edges of the bridge. And then this part is wrong. So they're in the opposite side, but the top row is correct. It is a RAID 5 because where it calculated for parity, that's where the parity starts to bleed. I see that all the time, and it almost doesn't make sense a lot of times, but I'll always see a block like this when the parity is off for the next row. Does this make sense to everybody so far? So this picture will make more sense after you see the rest of it go together and what the algorithm is. So, and then you end up with situations like this where your slices, like these slices are all okay, but then the alternating slice is not okay. So you're trying to hunt these down, and then finally you can get everything together. Here's the other one that I'll show you. That, now, I'm not kidding when I tell you, this is off of a RAID array, and I'm going to play a song for you, and it'll make sense to you after you hear it, but I'm going to play it for you. Hang it. I'm going to start it again. Hang on. one slice played, as long as it's in the same codec, it's still playable, and you'll see the first part of the song will sound this way, then it'll have a chop, it'll sound like a nice mixed collection. You'll hear the next slice. And the other thing I found that also makes a difference is VBR. You can have variable bit rates, and so the slower and the softer that a song is, so if it was like Beth, I Hear You Calling, like you'd be able to hear a lot more of the song into the amount of space than you have in 64K for the rest of the song. So as long as your player can play all of those, which I find VLC plays everything, even if it's corrupt, like it'll just play right into the next thing and switch codecs on you. So it'll actually work a lot of the time. So surprisingly, movies do exactly the same thing. I swear I've done this. I've been watching something and it'd be like, here's Family Guy, and then all of a sudden Homer Simpson's in there. And then, so there'll be a video that will chop up and they'll just play right into the same codecs. So I don't spend a lot of time these days watching, but I did in the beginning. I was like, how many examples of these can I have? It'll chop your music up and it'll play that piece, then that piece, and so on and so on. And so you have a good mix collection. But that actually works. That's actually the way that works. And so tomorrow morning we're going to do both the RAID 0 and the RAID 5 lab. We've kind of started covering a little bit of this, so I just want to get into the end piece here. RAID 5 is a redundant array, and it does have redundancy by parity. It is not a parity drive. People say that all the time. It is not a parity drive that is there. One drive is not storing the parity. It is distributed parity, and it's evenly distributed depending on which of the algorithms that you choose. And RAID, when it first started out, always had a discrete controller. So a discrete controller means I have a processor and it's doing the math for me. Later on, when we got higher into Intel processors and there were a lot of power that we were wasting, they decided, why don't we put this on the motherboard and not even have a host-based discrete controller, use a host-based controller. Host-based controller means I use your CPU from your computer. So a lot of new controllers that are, if they're under $300, it's probably a host-based controller. If it's over $300 and has a speed on it, it's got a discrete controller on it, so therefore it will do the math. And the difference is when a drive crashes in a RAID 5 array, you feel the impact on a host-based controller because now the processor's got to kick in and keep track of everything. Whereas on a discrete controller, it does all the work for you all the time. You'd never feel the weight of it. So on a server that has 8 drives on it, and the more drives you have, the more work it has to do, you would really feel it. If you had 8 drives on a workstation, your Intel processor could barely keep up. So it's really important for higher end stuff to have a discrete controller. And we're going to do all of this recovery stuff in software. Doesn't matter how many drives it is. I mean, I've plugged them in. I've had at least 60 drives in RStudio and done it before. And it does take time. Not kidding you, it takes a long time to extract the data, but it will work and you can do it. So we're doing all this in software. So those are the two primary kinds of ways that you'll have a controller. Now, RAID 5 is not these. The way that the parity works is it's distributed. So here's the parity, here's the parity, here's the parity, here's the parity. So any one drive dies, you don't lose it. And I'm going to show you my own animation in a minute. But I wanted to point out, ExclusiveOr is the function that's in between. So the parity is created by an ExclusiveOr function. So an ExclusiveOr function is basically going to give you this is what an ExclusiveOr function looks like. Let's see if I can get a good picture here. Like this. So if you have 3 drives in your array, everywhere in the bits, so it's every 8 bits in a byte, it's all hex by the time you're seeing it, but it's 8 bits in a byte. Every bit, everywhere that the 2 match, you have 0. And so if you have 2 match, it's 0. If you have 1 that's odd, then there's always going to be a 1. The idea is A plus B equals C. You can always reverse it and get the answer. Does that make sense? So this is all it's doing is it's taking all your bits, every stream of bit that you store. So you have 512 bytes inside every single sector. You have 64K of them. It takes those and maps out the exact opposite from that standpoint in your storage. Okay? So if in that particular instance, we do this. This is where I came up with the graphic. As an IT guy, I used to sell servers. So I had to sell servers. And if you did not buy a RAID 5 array, I mean, we're talking the late 90s, early 2000s, I didn't want to spend all my days at your building. I had 300 corporate customers in Atlanta. I didn't want to be spending all weekend rebuilding your server because you chose not to buy a RAID 5 array. If you did not choose to buy a RAID 5 array, I wouldn't work for you. I'd just be like, I'm not doing this. And believe it or not, that actually worked out really well as a selling position many times. I was like, if you're not going to do the right thing, I'm not going to work for you. So I'll see you guys later. Thanks. I always got the call back. I never, like, why? So what I did was I made an animation to show them why they needed RAID 5. I should have made an animation to show them why they needed backup after they got a RAID 5 because for some reason they still didn't think they needed a backup. So I did this animation wrong, but this makes the point, and I thought it was still pretty cool, so I'll show you. I should have done the parity distributed like it was supposed to be. I did not do that, and the reason I didn't was I thought all of these managers had taken a financial class. And they had A plus B equals C. And so they knew A plus B equals C. They could always figure out how much money there was and what happened to it. So I did this on that premise. I did A plus B equals C. Again, that's not plus. It's exclusive OR. It's an exclusive OR process. It's a mathematical process. So here's what happens to a RAID array when it's really running, right? So you have real data, 64K, 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 and then there's actually a parity slice here. So it's not on the bottom like I have it. So now all of the real controllers have an alarm that sounds not like that, but it's pretty annoying as a whole. And when it goes off, it lets people know, hey, you need to put a new drive in here. And here's the other thing I found out all the time. When they bought the new server, if they didn't buy spare drives with it, they didn't have the budget for a drive. Like you had to go and request it. It was painful. And so you would go and say, hey, a drive died in the server and you need to get a new one and we need it now because it's only supposed to live for 24 hours. So we need to get another one in there. Oh, why don't you put in a request and we'll see if we can get that approved. And you're like, well, all right then. I guess you don't understand. You're going to lose all your data. They still blame you in the end, even though he never approved it and you never got the drive. They'd always be like, why didn't you tell us how important it was? I did tell you it was important. So that guy gets fired, and so he's never there. But when you get it for a recovery, it's not because one drive died. It's because the next drive died, right? 2 drives in your array died at least. So 1 drive can die in a RAID 5, and it survived. But it is now recalculating parity on the fly because when I threw this X on top of here, that means this data no longer is real. That data is calculated from the parity in the row. A plus B equals C. I had to do the reverse calculation to make A2 work. Does that make sense? It's a very simple calculation, but it's a very important calculation, and it's a lot of data. And so your data is not real in reality. Every time I turn off a server like this, I'm like, ooh, I hope it comes back. Because it's not real data at that point. You don't have something that's real. It is now built on the fly. And every change that's made is then changed in the parity, and it's rewritten to the other parity, but never this one. So when you put a new drive in, it has to start the rebuild process, reverse all the math, and rewrite that drive back. Okay? So now a second drive dies, and now that's why you have it in for recovery, because the server kept on going even though 1 drive died. Now you get a box, there's 4 drives in it, and 2 of them are dead. 2 of them are real. Which drive do you need to recover? Think about it.
The original dead.
Why?
Because that would have the original calculated data.
Okay, so
You have parity.
what?
So you lost the data on the first one, but it had parity calculated, and the loss of the second one.
So let's say 6 months ago, this drive died. So what happened to the rest of the array after that death?
Still works.
Still works. So when I was reading my email and I responded to an email, where was it written?
It wasn't.
To one of those.
Yeah, it's still distributed across all of them. It's still distributed, and this data lives on. This becomes a virtual thing and is only recalculated by the controller and living in memory, basically. It's not, the whole thing is not living in memory. It's only doing the calculations based on what files and things you request on the fly. So the data that would be A2, it doesn't need to worry about this parity at the moment, but it doesn't matter. It's redoing the calculations for everything all the time on the fly and making it alive. Does that make sense? So all of these changed. That changed, this changed, and that changed. All the data changed everywhere, all the time, 10 minutes after the first drive died. Now, another drive dies. That's when the whole thing goes down. At that point in time, that's when the whole server stops running. So this drive dies, the whole thing stops running. So now, what you need to know is which one was the last drive to die. The one that's the last drive to die is the only one that's in sync with the data. He's the one that took the whole thing down. So if I get the data from the first drive, he is out of sync with this data now. And here's another thing that Dell does all the time that's horrible. People say, like, they'll tell them, I'm not going to take that back for warranty till you test the drive, so I want you to go into the control panel and click Force Online. Do not do that. Never do that. What happens is you say this drive is actually okay, and then redistribute your data back to all the others. And it corrupts all the data on all the other drives, because now you've told it, I don't care what you say, I'm right as a human. Do what I told you to do. And it will take this data and redistribute it back into the parity of all the other stuff, and it will screw up all the data on all the drives. So you cannot do that. I do not do drives live in the array anymore like that at all to try to get around this kind of problem, because what I want to do is protect these other drives. So the two that are still alive, I either image them or I never write anything to them, because I can put them on write blockers. I can even put them on SAS controllers because they have no MBR. Right? Only one of them has an MBR. It's the only one Windows is going to try to see or mount or do anything with. So if I put them on a deep spar and I fly through the deep spar, I can see which ones all have that are working, which ones have the MBR. I can see all the stuff I want to see. Repair the other two. I've got to get one of those working to know which one I need, because you don't know which drive you need. You know you need the last one, but you don't know which of those two that died unless somebody told you. Because where is the log file that tells you which ones of the server died? Right? Where is the log file? Everybody know? Where's your RAID log file right now? If you have a RAID array and on a server, where do you keep your log file? On the server. It's in the event logs and in the logs for the RAID array. Unless you have an SMP server. A big company, if they were smart enough to have an SMP server, then they're not in this condition anyway. So, because they have a network management module server that's keeping track of all of the stuff and alerting people when things go down, and they already would have had a drive. The small business servers are the ones where the log is sitting on the server in the configuration, and it'll tell you which ones died. But you don't have that luxury because you don't have a running box. You can't find it. Now here's another amazing thing that happens. If you were to, let's just say that this drive was hobbling. It's in bad shape, but you can read some of this drive. Here's the amazing thing. Your MFTs are distributed. So if your file for your MFT is large enough, 64K isn't large enough to contain it, so it distributes across all of the drives. So if you look at the files, the file listing, file records, and you separate them out like I did with the get data back, and I separated out all my MFT entries, you can tell by looking at the dates in the MFT. So if I was in the MFT and the good drives that are alive, say yesterday's date or last week's date before it died, I can see that in the MFT entries. When I get this drive running well enough, I can look at least some MFT entries and say, what are your dates? And if it says September of last year, Well, that one's probably the one that's the wrong one. It's probably, I probably need something that's more current. I could actually look at the MFT entries and figure it out. Does that make sense? I mean, I can use a hex editor. I can go find it. And then I can parse it. And then I can put it in the disk utility that I showed you earlier where it parses every record. I can extract $MFT from one single drive, and it'd just be the file records for that one drive because they're 2 sectors each. Everybody get where I'm going with this? So I can do 2 plus 2 and figure this out. But you still have to rebuild the drives. So you have to rebuild. Now, here's the other thing. In a RAID array, where are your donors? Because people with RAID arrays don't like to wait. They don't want to wait a week for you to ship a donor drive. So where's the donor?
The drive sitting next to it.
That's right. The drive sitting next to it is probably identical. They are probably all bought at once. They probably all came together unless over time warranty replaced somebody's drive or something like that. They're probably all the same. So when people buy a server in a RAID array, most of the time I find that the drive next to it is either really close or really similar enough for me to use. So what you do is you tell your client you're going to destroy it. I would have charged you for it anyway. So I'm going to destroy this drive. But I'm going to make a backup of this drive first. So I'll make an image of this drive and save that over to the side. Now I'm going to tell you I make 2. I don't make 1, I make 2. Because if you do all this work and any drive dies and your own drive dies, you're screwed. You've done all this work for nothing. So make 2 copies of this image or compress them as encase images. I don't care how you do it, as long as you protect this on 2 different drives. Then take this drive apart, rebuild that drive. Look at the content on the drive. Is this one going to match? Can I rebuild this drive? If it's incorrect, then you go, oh crap, now I've got to rebuild that drive. So same kind of thing. If I've got to rebuild that drive and I destroyed this and destroyed that, then make 2 images of this one. And then you take this one apart and you rebuild that one. And in the end, you'll have no real drives, but you'll eventually get all the data. That's all the client's going to care about, I promise you. They won't care about these $200 drives. They're going to care about, I mean, you're charging them, I promise you. In my case, this is $3,200. I'll make $3 grand doing a RAID array like this right off the bat. So they're not going to care about $800 worth of material. They want their data and they want it now. So that's what will happen. That's what I'm trying to do. Everybody get where I'm going with this, okay? So you do have to figure those things out. If nobody knows which drive died first, so I found that the only people who know which drive died first, the IT guy, if he was not fired, because he usually does get fired. I'm not kidding. He's gone. He's already like, oh, I'm out of here. These people are going to have a big problem. I'm not going to be here for it. I'm out. Or he gets fired. So the maid. The maid still comes and cleans up the server room, and they will notice a red blinky light on a server that never had a red blinky light. So if you ask the maid, she might actually know. I'm not kidding. So if that's an easy phone call to make, that's what I'll do. Otherwise, I'm doing it myself. But it is a lot of work to rebuild a drive that you might not need. So if I rebuild that drive, I cannot put it back in if the date is the wrong date. The chances of it being correct or incorrect are different. Now, there's only one other scenario that happens that I've run into often. A drive did die. That drive did die in the array. They did get a new hard drive, and they put it in. And the drive started rebuilding. And the IT guy knows this. He'll see it. Oh, yeah, it looks like it's rebuilding. It's great. Okay, 10%, 12%. It'll take 24 hours or whatever it is for the size of the drive to rebuild, right? He leaves. Comes back tomorrow, server's down. Turns it back on, turns out this drive died. So this drive died while this one was rebuilding. Now you have 2 RAID arrays. Not 1, 2. Understand what I mean? From wherever the server died rebuilding this, from there to the end of the drive is blank. So you can figure out exactly where it was and it rebuilt. And this part up is with A plus B plus C and parity. So the whole thing is intact up to that spot because it rebuilt it down to that spot. But there, from there down, you now have a missing disk, and so it's these that are going to survive minus that because that is blank. So you actually have to process it and divide it up into 2 separate RAID arrays, rebuild the logical area, and then glue them together. Does that make sense to everybody? There is a way to rebuild it in software with a missing disk. So I have to knob this off and I have to say, all right, well, it's 10 terabyte. Here's 5 terabyte that is the first one. And then I take 5 terabyte from all the drives. And then I make a RAID array. Then I export that RAID array as one. And so if there was 3 5 terabytes, then I have 10 terabytes I have to export. If it's 4 5 terabytes, I have 15 terabytes I have to export. And then I rebuild the second half with just the 3. Does that make sense? Now the 2 of them I have exported with their logical setup and I glue them together. And hopefully they aren't that large. Most of the time they're not. Most of the time I find 4 terabyte drives. That's usually about what I have for most of the ones coming in. So everybody okay with this so far? So we'll go over the rest of this in the morning so that we'll do the labs, because I want to go through with you what we're actually going to do. But fundamentally what it will look like is this. You have 4 items that you can really deal with as a whole at this point. So you don't know your disk order. Maybe you don't. If you actually got to talk to the people or they did them in the array, they labeled them, that's great. I get a mystery box all the time that they just pulled drives out, put them in a box, send them to me. And most of the time I can tell them more than they can tell me. I can tell them what controller they used, when it was, what happened. But if you can get them to tell you anything, it will cut down on the amount of time that you have to deal with it. Because if somebody says, oh yeah, it's a Dell server, well, you know you have a PERT controller, now you know the layout. You already know what it's going to be. The only thing you don't know is slice size. It's the only thing you don't know. And if they labeled them and put the numbers on the disk, you know the disk order, so you don't have to play with that. I have seen them do them wrong. I have seen them number them wrong and figured it out. So here's basically, this is all the words to back up all the stuff I just said. But this is the layout. So now watch what happens. Every cheap server, and I call Dell a cheap server, everything Dell and down is going to be left. The word left is always going to be included in the layout. If they are expensive servers, Compaq, IBM, HP, any of those, all those in that high-end category, they're all going to be right. They're all going to be the first word's going to be right. So there are 4 variations. So watch what happens. Here's my drive. 0, 1, 2, 3. So watch the count. 0, 1, 2, 3, and then parity, 4, 5, 6. And then 7 skips. And then 8 skips. So you got that over and over. Okay? Watch the next one. This is also left. The first one's left asynchronous. The second one's left synchronous. 0, 1, 2, 3, 4, 5, 6, 7. Remember the picture that had the bridge? And the bridge should have been over here, but this piece got moved over there, so you get an alternating order. These are the orders that happen. This is what happens as the squares move. Now, the next set is going to be right. So the parity goes to the other side. So watch. Right synchronous, right asynchronous. Parity comes down this side. And you have the same thing. 0, 1, 2, 3, 4, 5, 6, 7. Top row is the same again. Watch. 0, 1, 2, 3. But now 7, 4, 5, 6. Get what I'm getting at here? So when you pour in the JPEGs or graphics, the top row is the same. The top row will work for all of them. And when you get the top row right, you have figured out the drive order. Then the second rows and so on from there, you're usually dealing with slice sizes. So once you get the drives in the right order, you only need to know if it's right synchronous or right asynchronous. So same kind of thing. Again, I'll show them to you again. Left asynchronous. So the one of them is AMI and one of them is a PERT. So it's a Adaptec and AMI. Those are the 2 in that category. They're always going to be left, and everybody uses those configurations. We haven't had any different configurations from brands since 1999. They all went out of business. Everybody else that's left does all 4 of these variations, and the only ones that are different are the expensive ones, like HP Compaq adds another delay. They add another parity into the row, and you just have to know where it is. And JFFS, same kind of thing. And all of these things can also be figured out by Reclaim Me, UFS Explorer, or there are some special compact ones as well, but they'll have configuration files in them. And the configuration files are also sometimes on the disk, even in cheap ones, with serial numbers of the drives that belong to them. So left asynchronous, again, the row is the same. The second row goes in this order, but in the next time it's changed in this order. But the top row is the same, and the same thing for right asynchronous and right synchronous. So they all are the same. Those are your only 4 variations. Everything else has to have big dollars applied to it. And if you show up with an HP compact RAID array and 16 drives in the array, well, there's a lot of money involved in it for me. I don't mind spending $800 on Reclaim Me Pro to do that drive if I had to. I don't need to, but because you can look up HP compact RAID arrays, but 16 drives, it'd be quicker for me to do it in Reclaim Me Pro. I can do the layout myself. Reclaim Me Pro will eventually figure it out, but it will take it a long time. It'll take it a long time on its own. So anyway, so that's what I would be doing. So I'm going to be looking for the drives, and the order that I typically look at things, if they are good drives, especially with the size today, I don't normally fix every good drive. I keep a stack of them, and I'll talk about controllers tomorrow because there's an easy way to solve all your controller problems. You cannot hook these things up through USB. That concept that you're going to use USB, or that you're going to make an image of every hard drive and put it on a server, or a big hard drive, you're going to have to work on some drives that are live. There's not going to be an easy way around it at all. So if you have 16 drives in an array and they're 4 terabytes each, where are you going to write them all? You just can't. There's just not an easy way to do that. So I'll deal with the bad ones, and I'll have 2 or 3, and I'll mix those up with good drives, and they won't mess up in Windows because they won't be mounted in Windows because they don't have an MBR. Only the first one does. So that one I make an image of. The others I don't have to. So anyway, fix them, and then it looks like this. I'm basically looking at the differences in slice sizes, and I'm going to look at the pictures and the difference of the slice sizes. This is how you look up a header. So if you're looking for a header, this is how I looked up a JPEG. This actually came from Wikipedia or whatever. And so you're looking for JPEG. Here's the start, FFD8. Here's the ends. So it'll tell you down here, FFD9 is the end. So all you're doing is taking the data from the beginning to the end and cutting it out, and saving that, and you have a picture, and that's it. So I'm using this data to get the EXIF information. You see this? The camera, the date and the time. It'll also have the megapixel. It'll tell you how many megapixels, or basically its size. So when you look at this picture, that's the EXIF information from the picture. And I cut that out of this picture. I literally took this, got the beginning of it, so I get the EXIF information by default, and then, because the picture is damaged, I don't have a whole picture. And when you highlight it, you'll see this says it's 8K, but that picture cannot be 8K. If you take those dimensions and you type them in, and they were taken with a good camera, you'll get this. You can figure it out, 10 megapixel, and at the right quality, it's going to be somewhere in the neighborhood of a 2 meg picture. So somewhere around 2 megs. So if that becomes a 2 meg picture, and you finally can see the picture, I start breaking it up by size and site. So the first kind of thing I do is I look and I say, hey, do all the pieces belong in this picture? That way I know I have all the drives and all of this goes together. It shouldn't be a random number of other information in there. And so you can see her head has shifted over, and then what slice size do I have? So you can tell as you start counting through it and start halving everything, you can see how big it is. And so does the layout look the same? So then when you look at this picture and you look at the layout, what will happen is you'll see on a left asynchronous, you'll see that your blocks are in the wrong order. So when you switch them to the other order, then all of a sudden these pieces will go together. So you switch the order. So I'm looking at the row, and then I'm looking at the breakdown of the squares. So that's not a random picture. She actually used to work for me. She said she wanted to go work for the FBI, but she went to LA and she was in Fast and the Furious and a couple other movies, but she was like an extra. So she wasn't doing all the other film. Anyway, so she could not be in the FBI. I'm just going to tell you. She was not that smart. So anyway, so There is also code that will do some of this work for you if you wanted to do it by hand, but I'll show you a way quicker way to do it in the morning, and we'll figure out rate arrays in minutes by comparison to what you can do with most of the automatic programs. Okay? Everybody exhausted and ready for? All right, so tomorrow morning we're going to do RAID 0, RAID 5 labs. Okay? (6 a.m.)